Hello everyone, I am Abhishek John. Now I am going to explain about practice number 5 in computer organization and architecture. So this develop performance of non-pipeline and pipeline execution. So that's our practicum. So let's move to the coding section. So this is implementation of arithmetic addition using non-pipelined method. So we will just giving an array of data, then we will just give the length also. So length of data, length. So it will 1, 2, 3, 4, 5. So as the n, then we are just giving a result is equal to 0. Then now we are just going for non-pipelined execution. So you are just starting the timer. Then for this is the MATLAB function for the for loop. So for I is equal to 1 to 5, that n, 1 to n, the length of the data. So we will just data of 5, we are just adding the results. So result plus data of a result, we just initialize to zeros, then so it will be add, then elapsed time is equal to. So that is the non-pipelined execution. Now we will just go to the pipelined execution. So final result, which is the not pipelined, then execution time. Sorry, I mean non-pipeline result. So we just printing that result. So this is for the non-pipeline execution. Then just we are going for the pipeline result. So as like the saying, we are just getting the input, getting the data value. Then pipeline stages is equal to 0. So we are just initializing 0 from 1 to 5 and to n. So I just doing this. Then displaying pipeline execution, then starting the timer, then as usual 1 to 5, then pipeline stage is equal to data. So this is the difference in pipeline execution. So the result is equal to sum of pipeline. So the result and timing plus sum is equal to this, the shortest way to get the summation, which is the pipeline method. So final result pipeline and the execution time will be printed. So this is the output for the pipeline execution. So for the pipeline execution, it took 0.0004004, but here it is 0.009. So the execution time for the pipeline is shorter than non-pipeline. So that's the code here. So coming for the additional question, execute the MATLAB program for non-pipeline and pipeline execution in the same number of instruction blocks. So we are executing for both non-pipeline cycles and pipeline cycles. So first we are initializing the k value, then n value for as an array. Then the non-pipeline is the formula here. We are applying the formula non-pipeline is equal to n into k. Then for pipeline, it is equal to k plus n minus 1. That is the formula. Then speed is equal to non-pipeline divided by pipeline. That will be the speed of the current instruction. So instructions non-pipeline, pipeline, and pipeline is speed up. So you display. That's the display. So the table data is equal to we will just display it in tabular form. So n the non-pipeline is speed. So display table data. So it will be this. And how pipelining improves throughput. So throughput in pipelining. So NKT. So non-pipeline cycle, as we know, n into k, non-pipeline time is equal to non-pipeline cycles by time. So pipeline time, non-pipeline time is equal to the cycles. Time is equal to cycles into time. So non-latency is non-pipeline. The latency for the non-pipeline cycle is k into t. Then we are going for pipeline cycles k plus n minus 1. Then pipeline time is equal to pipeline cycles into t. So non-pipeline, it is for non-pipeline cycles. Then pipeline time equal to pipeline cycles into t. Then pipeline latency also it is similar to non-latency k into t. Then for the throughput, non-pipeline throughput is n divided by non-pipeline time. Then pipeline throughput is equal to n divided by pipeline time. So we are just displaying everything. So this is our output. Then stall cycles on pipeline execution. So we are just seeing the effect of stall cycles in pipeline. So next to the n value, k value, s value. S value is the stall cycles due to the hazards. Is coming due to hazards. So ideal cycles we are just giving k plus n minus 1. Then stall cycles k plus n minus 1 plus stall. So for the stall cycles we are just using this is the ordinary pipeline equation. This is for the stall cycles equation. So we are just using the num to string to converting it to regular value. Yes, we are doing. So for ideal normal pipeline cycle it will be 14. Then pipeline cycle with the stall we are just adding 3 is equal to 3. So we are just adding 3. So that's for the practical number 5. So thank you.